So before I begin, let me give a huge thank you to the whole staff here. I know running one of these is a lot of work, and I think we're all very grateful. So as you heard, I'm Cameron. I'm the product lead for Go at Google. I've been a PM on the Go team for a little over 3 years now, and it's really just been the highlight of my career. I get to work with some of the most talented people in the world, and then I get to come see a dedicated community like all of you actually use Go and build awesome products. And that community is really the best part. So, thank you for all that you do, and please keep it up. Good. So today, I'm going to tell you about the state of Go. And the short of it is that the state of Go is strong. But before I tell you why, I'm going to recount how we got here. Now, I wasn't there. But the story is that during a 45-minute C++ build sometime in 2007, Robert Griesemer, Rob Pike, and Ken Thompson scribbled together a vision of what would ultimately become Go. According to Rob Pike, some Google employees had recently given a talk on all the new stuff that was coming out in C++ 11. And in the span of about an hour, he counted something like 35 new features that were being planned. And somewhere in there, he asked himself a question. Did the C++ committee really believe that what was wrong with C++ was that it didn't have enough features? Surely it would be a greater achievement to simplify the language rather than to add to it. So Rob made this observation in the midst of a period of tremendous growth at Google. The breadth of Google's products and services was growing, usage was growing, and the engineering teams at Google that build all of that stuff and maintain it was growing too. So this slide shows us how Google's headcount grew between its IPO in 2003, when it had a little over 1,600 employees, to when Go 1.0 was released in 2012, when Google had grown to over 50,000. So this meant a lot more people writing a lot more code, and then coordinating all of that carried a ton of more overhead. And since Google's business is all about scale, this problem was only going to get worse. And this is where Go was born. Google was struggling with this scale. The complexity of a massive code base with so many developers working on the same projects in Java and C++ had led to brittle code and diminished productivity. And Go's vision was, hey, let's prioritize this scale. This means accounting for how modern software is architected, the environments in which modern software runs, and then most importantly, the teams that write, operate, and maintain it all. So on that basis, from when Rob, Robert, and Ken started all of this in 2007 to when Go 1 was released in 2012, the Go team worked to define Go's founding principles and build it for release. So this includes making it an open source project, which we did in 2009, and then ensuring that what we call Go 1.0 is usable, and in part by putting it in production. So one of the key bits in Go 1's release notes is this kind of emphatically stated point. The driving motivation for Go 1 is stability for its users. People should be able to write Go programs and expect that they will continue to compile and run without change. So some programming languages are good at this, some are not. We're going to be really good at it. In fact, we also released Go 1 with a separate document that explains our compatibility guidelines in detail. It's called the Go Compatibility Promise. So there we wrote, it is intended that programs written to the Go 1 specification will continue to compile and run correctly, unchanged, over the lifetime of that specification. Go programs that work today should continue to work even as future point releases of Go 1 arise. And the reason the compatibility promise is so important is because what we sought to release in Go 1 was not just a programming language, but rather a platform for software engineering. So the vision wasn't to compete with C++ on the number of new features we could release. The vision was to facilitate real software engineering at scale. So that sort of software, it's written in teams, where members come and go, where there are deadlines, SLAs, all of that. And that sort of engineering really requires long-term predictability, not breaking existing code or creating some sort of perpetual maintenance burden. It also requires accounting for the fact that software development is more than just the programming language that you use. It's this multi-stage life cycle with all these different intersecting tools. That's the idea of a platform. So in addition to the compatibility promise, Go 1 shipped with all the stuff on this slide too, all of it out of the box. So instead of importing like a third-party library for testing or finding and agreeing on a style guide, Go 1 started on this mission of providing our developers an entire platform for everything that you need to ship good, scalable software in teams. And what ended up being another important decision, this stuff that came out of the box was all accessible from a single command. So from the start, Go was mindful of every link in the development chain, all the way to the developer's command line. So with the Go command, we established the first developer touch point, sort of like the entry into our platform. And it's one that continues to be a very important means by which we're able to ship a unified end-to-end experience. So that was version 1. Next, between 2012 and 2015, as developers were beginning to adopt Go, we focused our efforts on refining everything. So like any software project, the first few versions had all these rough edges, and actual usage really helps you see that. So for Go, this was a multi-year process culminating in 2015 with Go 1.5. So by Go 1.5, you could say the platform was more or less refined. For example, the compiler and runtime were completely rewritten from C to Go. This is like sort of one of these important rites of passage for programming languages of this sort, where the compiler is written in the language that it compiles. The garbage collector was another sore point in the very first releases. It was slow, but we introduced a new garbage collector in 1.5, which reduced overhead and pauses to levels similar to what you got in other garbage collected runtimes. Stepping back to like the project level, it turned out that a predictable release schedule provided developers a lot of value because it allowed them to plan their own releases around ours. So Go 1.5 is the first version where we committed to our semi-annual release cycle, and that persists today. And more generally, Go 1.5 had a hardened standard library, runtime performance was improved, and just various other things were fixed or improved throughout. But despite all this change, the compatibility promise from Go 1 still applied. As we wrote in those release notes, version 1.5 is a significant release, including major architectural changes to the implementation. Despite that, we expect almost all Go programs to continue and compile and run as before, because the release still maintains the Go 1 promise of compatibility. Now, we saw on the slide earlier that Go 1 had a form of primitive dependency management, but in 2018, modules were introduced, which really represented a fundamental shift, one, in how Go code was written and packaged, and two, how Go code, especially third-party libraries, was distributed, and then the ecosystem that followed that. So to this distribution point, before modules, you would go get your dependencies from their origin, which is most likely GitHub or wherever else. And then the introduction of modules didn't change that. But an important property of modules is that their contents for each version are immutable. And this provides opportunities for caching and authentication. So modules themselves were introduced in Go 1.11 and Go 1.12, along with the Go mod file and the Go mod command. These things fundamentally changed how Go libraries are packaged and versioned. But in Go 1.13, we then took advantage of that immutability property that I just mentioned to introduce the Go module mirror and checksum database. So now with the module mirror, we could cache all these libraries, and because we know they're immutable, we can serve them much more efficiently, which makes dependency downloads much faster. And then by caching them, we can also protect you from your dependencies disappearing from their original locations. And then separately with the checksum database, we were able to store a hash of all the source code in all of these dependencies, which allows us to detect whether they've changed since we last saw them, which protects against stuff like man-in-the-middle attacks and other tampering of your dependencies. Now, the module mirror and checksum database don't tell you whether a dependency has a vulnerability to start, but by recording the hash the very first time any Go user imports a dependency, we can then detect whether that module changes on any subsequent import by any Go user anywhere. So in this way, the module mirror and checksum database are able to ensure that the bits that you or anyone else get the first time are the very same bits that everyone gets every subsequent time. So this capability started this new parallel consideration in our development focus. We realized that as Go was growing, especially in these huge, important infrastructure projects, the importance of security was growing as well. So now, in addition to being a complete, refined platform for software engineering, Go also sought to be a secure platform for software engineering. So we talked about modules and the module mirror and the checksum database. And around the same time, we started seeing a lot of really high-profile software supply chain attacks. This is the kind of thing where an attacker would inject a vulnerability in some commonly used open source library, and then this would affect huge swaths of language ecosystems. Like you can think of Log4Shell in Java. And that's where we really leaned into Go's security posture and capabilities. In Go 1.18, we introduced support for SBOMs, or software bill of materials. And so this means that the Go compiler writes into every binary that it builds all the versions and dependencies in the source, which then allow you to later verify that everything is correct with just the binary. In Go 1.18, we also introduced a built-in fuzzer, the first major programming language with native fuzz testing built into and integrated with its standard toolchain. You can think of fuzzing as a form of automated testing that intelligently manipulates inputs to your program to flesh out bugs, and especially security vulnerabilities. So because of the module ecosystem, you can now fuzz a specific version of a module, and if you discover a vulnerability, you can report the results of your fuzz test to the package maintainer, and the maintainer can then reproduce your results guaranteed. And then most recently, we've introduced our end-to-end vulnerability management system, which surfaces known vulnerabilities in your dependencies everywhere, from your IDE to runtime. This one just launched in July, and I think it deserves a little more time, so I'll elaborate on it later. It's really cool. Now, the introduction of modules and the security focus that followed coincided with this other really important development. Go was becoming increasingly important in industry. For one, the entire cloud was being built on Go. This includes GCP, AWS, Azure, and all these other important different tools and services that were sort of becoming a core part of cloud-based software development. Enterprises began to adopt Go as well, using it for really important business-critical systems and infrastructure. I know some of you in the audience are from these enterprises, so you know this firsthand. And inside the Go team, all of this use and adoption led to this sort of acknowledgement of Go's new criticality, a realization that attacks on Go can cause some major problems, which validated this focus on security and made it even more important for us. So I mentioned that a lot of the security stuff came out in Go 1.18, but there was this other, pretty important non-security related change in Go 1.18, which is, of course, generics. So generics were the single most requested feature of all time and the most significant change we ever made to the language. In the years leading up to Go 1.18, there had been all this talk about doing this relatively larger overhaul that we'd call Go 2. And in fact, the compatibility promise I showed you earlier, it actually specifically carves out a possibility for a Go 2, one that would be potentially incompatible with Go 1. And leading into the work that eventually became Go 1.18, we realized, this might be Go 2. Generics in particular, they were not only the biggest change that we ever made to the language, they're likely the biggest change that will ever be made to the language. But it wasn't Go 2, it was Go 1.18. And the question that always arose with that caveat in the compatibility promise was, well, when will Go 2 happen? And we announced this last year and we'll announce it again. The answer is never, or it's already happened. There will not be a Go 2 that breaks Go 1 programs. There will be major revisions, like what we saw in Go 1.5 and Go 1.18, but they'll never break your programs. Instead, we've actually doubled down on compatibility, which you may have seen in Go 121, because that's far more valuable than any break with the past. In fact, we believe that prioritizing compatibility was probably the single most important design decision we made in Go 1. So as always, every release of Go has and will maintain the Go 1 promise of compatibility. And that brings us to today. Now, thinking back on that history I just laid out in the last section, you can kind of imagine a series of layers that build on top of each other. The core stuff, like the language, compiler, runtime, and standard library, they're all introduced in Go 1. Modules were a paradigm shift beginning in Go 1.11. And then our latest security focus, this stuff that goes beyond modules, it really began at Go 1.18, where we introduced SBOMs and fuzzing, and now we're on to vulnerability management. So the next important piece to consider is how we continue to provide a platform. So earlier I emphasized the significance of the Go command in Go 1. That's this important developer touch point, and it's the means by which we're able to ship this unified end-to-end experience. But along the way, we expanded into these other important developer interfaces that enable us to really expand our definition of what it means to be a platform. So the Go command itself, of course, it's the original. It's the one you get at the command line. But our web properties, go.dev, package.go.dev, they enable us to provide this rich experience for ecosystem discovery and documentation. So for example, we recently added the vulnerability data that I alluded to our package site, bolstering the ways in which we're able to deliver security-related information to Go developers at more stages of the software development lifecycle. And more recently, in 2020, we took ownership of the Go plugin for Visual Studio Code. So this allows us to consider how developers can use the things that we build at the earliest stage of their work process, in the IDE itself. So when we released generics in Go 1.18, for example, we were able to ensure that generics were available in VS Code on day 1. Vulnerability data was also integrated there as well on day 1. So that's the platform as it exists today. Now let's take a look at adoption. So I'll start by saying that there's a lot of different ways of estimating how many Go developers there are. And it's really difficult to land on any particular way of measuring this. What I've done in this case is I've taken the proportion of respondents who report using Go on Stack Overflow's annual developer survey and multiplied it by Slashdata's estimate of the number of developers worldwide in each given year. And when we do that, the state of Go looks really strong. We have 4 times the number of developers this year than we did in 2018. And between 2022 and 2023, we took on 1.2 million new developers. That's a lot of new developers. And I'll return to that observation a little later. Existing developers are extremely satisfied as well. So not only are we growing well, but once developers start using Go, they're pretty satisfied with their experience. So this is important not just because it validates our work or bodes well for future adoption. It also means a lot for team happiness, culture, recruiting and retaining talent, part of that core mission of optimizing for software that's built by teams. And we think there will be more of this to come. Go is consistently in the top languages that developers want and plan to use, and 2023 has been no different. This slide from earlier this year shows that more developers said that they plan to start using Go this year than any other language. We're sort of used to hearing this kind of thing, but it's really remarkable, and it's a fantastic leading indicator of what's to come. Which brings us to how we think of Go today, and the work that we're doing now, and how we'll continue to pursue the core vision that started this project in the first place. So all those things that we learned in the last 13 or 14 years, sort of the things we focused on, the impact we had, I think it reduces to the mission in the title of this slide, that Go provides the most productive platform for building production systems. It's productive because it's easy to learn and maintain and scale across teams. It's a platform because it's more than a language. It's an end-to-end developer experience. And it's production ready because it's reliable, efficient, stable, and secure. So this is the framework that we use to think ahead. Now for where we're going next. So first is the work we have underway for making Go more productive. So we released generics last year in Go 1.18, but we continue to improve on it now, including in the standard library. So in Go 121, which we released in August, we introduced new maps, slices, compare packages, Go's first and certainly not last generic standard libraries. We're also making these ergonomic changes to the language itself, including this long-sought proposal to the loop variable semantics and another for standardized iteration. You may have noticed that we've included a preview of an experimental implementation of the change to loop variable semantics in Go 121. We'll ship that. We plan to ship that in Go 122. We're improving onboarding. So as I said earlier, we take on a lot of new developers every year. From the Stack Overflow number I showed you, more than a third of Go developers only started using Go in the last year. And as we saw on the slide from earlier this year, more developers said they plan to start using Go this year than any other language. So we need to think about these developers and their experience so that they can quickly get started and be more productive, and then also to continue to use Go productively after that. And I should say that we really think of onboarding very broadly here. You can even think of things like error messages, linking, documentation, all that stuff, all those improvements. They improve onboarding. They help new users be productive, and an important side effect is that when we help these new users be more productive, we almost always help all users be more productive, including all of you. Next, we continue to think of complete, cohesive solutions that reach all of our developer surfaces. So remember, it's not just a language, it's an experience. For example, this year we've started to survey package maintainers to understand what we can do to better support the package ecosystem that is this huge part of what makes Go so powerful today. We also continue to make our developer touchpoints more useful and robust. We recently made a bunch of really important scalability improvements to GoPlease, the LSP server, including integration of on-disk indexes. This cuts GoPlease's startup latency and memory usage by 3 to 5 times in typical use cases, which makes every IDE that relies on GoPlease substantially faster, especially for larger code bases. And our VS Code plugin continues to get better, more integrated, including by integrating with our new vulnerability management system, which brings us to the vulnerability management point I said earlier that we introduced we launched into GA in July. What is it? So we have a lot more detailed materials on this online, so I encourage you all to go look for that on YouTube or on go.dev. But the short of it is that the Go team has created a comprehensive data source of all known vulnerabilities in the Go ecosystem, which we've done by pulling vulnerability data from all these different sources like GitHub Security Advisories database and direct reports from Go package maintainers. Vulnerabilities from all these data sources are individually reviewed, curated, and then aggregated into the Go vulnerability database. And then probably most importantly, we've made all of this data easy to find and use, most of all by integrating it across all of our developer touchpoints. So you can learn about the ones that might affect your dependencies on our package site, say before you choose to use a dependency, and then you can use our command line tool to check if the command line or CI, and you can detect and fix vulnerabilities in your IDE as well through integration with our extension for VS Code. So this is all the latest example of how, by focusing on building a platform, we've been able to create these kind of like end-to-end solutions at all stages of the software development lifecycle. And finally, we continue to make Go production ready. Performance and reliability are a huge reason that developers choose to use Go, and we want to make sure that we're still, leading the way. So, having doubled down on compatibility, we've taken steps towards ensuring that you can, if needed, emulate behavior from older versions of Go. So, like if the change to loop variable semantics that I mentioned surfaces a bug in how your code uses loop variables, we've made it possible to force compatibility so you won't have to worry about breaking when you upgrade. So all of this compatibility work was actually a big part of Go 121, sort of set the stage for the future. We also released PGO, or Profile Guided Optimization, in Go 121. PGO enables the Go compiler to read a profile of your program, one that you collected from an earlier build at runtime. And then it spends more time optimizing the parts of your program that run more often. In our benchmarks, we've actually seen improvements in CPU usage of about 7%, and I've heard even better from some big external customers who've tried it out as well. On the performance and debugging and monitoring side, we're exposing more metrics for the garbage collector. We're writing a garbage collector guide, working on execution tracing, and ensuring that Go works better with the Linux perf tool. And our standard library is seeing some really important new functionality as well, like structured logging, which Jonathan Amsterdam from the Go team will talk about more tomorrow. And then there's AI. Now, I wrote here AI-powered applications. That's because I want to distinguish between the two different things I think of when I think of AI. First, I think, what can AI do for Go? And I think the answer here is going to be the stuff that AI does for all languages, and software engineering in general. So there's going to be stuff like code assistants, chatbots, stuff that sort of make developers more productive when writing any kind of code. I think this is probably the better defined area of AI, and it's the one that's easier to understand, and it's probably mostly language agnostic. But second, I think, what can Go do for AI? So in other words, how do we make it easy for developers to infuse AI in any form into their Go applications? How do we ensure that the community, library maintainers, Go developers, that they all have the tools they need to make writing AI-powered applications just as easy and productive and powerful as Go has done for everything else? So, how can Go make AI better? So when we surveyed Go developers on this earlier this year, a lot of you expressed interest in this, especially for integrating Go services with LLMs. I think we'll see this interest grow a little more as time goes on. And the questions we're most interested in now are, how are Go developers using LLMs or other ML models today? What does that journey look like? What are their pain points? What about Go library developers? Is there anything missing from Go that makes it harder to build quality AI-focused libraries? And then what can we do as the Go team to smoothen all these experiences and ensure that everyone can continue to deliver sort of high-quality production-grade applications? So when I look at the AI space so far, it's complicated. So you have LLMs as a service, like what you might find on Google Cloud or with OpenAI, or whatever company Sam Altman builds to supplant OpenAI. You have others hosting their own LLMs, maybe something off of Hugging Face, wrapping them in their own APIs, sort of like a do-it-yourself model. And then you have all this surrounding infrastructure, like orchestration libraries like LangChain or Llama Index, and stuff for ML ops, vector databases, processes to tokenize your training data. It's all quite a bit. And then we also see that it often involves Python, which makes sense. Python is the language of choice for exploring data, defining ML models, and then fine-tuning them, stuff like that. It's interactive. It's easy for data scientists to use. It's really the right tool for that job, exploring data and creating models. But it's probably not the right tool for serving production-grade services, the ones that use these models. And that's sort of created what I think is a bit of an impasse or scalability gap here. When folks are using these Python models, training them, tuning them, they can get stuck using Python in production. And so that's the thing that I'm referring to when I say AI-powered applications. Productionizing and serving these AI-infused applications in Go. So this is the one that we want to explore further. How can we ensure that Go continues to be the productive, performant, reliable, and secure choice for serving these applications? How can we ensure that developers continue to reach for Go for the scalable production components of their AI-powered products? So I don't really know the answer to that, and it's really early days here. It's possible there isn't anything to do at all. All of this will shake out as it should, or maybe it's all a bunch of hype. But we're keeping our eye on it, and for our part, we want to be sure that we enable the community to keep Go on pace. So my ask of all of you is go out there and try this stuff out, write tutorials, create examples and documentation, find libraries to contribute to, and then write me an email to tell me about it and what the Go team can do to help you. That QR on this QR code sends an email to me. Send me your ideas because I really do want to hear them. Which brings us to the last section. Even if we do all of that work to make Go the most productive platform for production systems, and you all helped me with the AI question, why do we think we'll succeed? Well, the answer is actually right here. It's Go's community. Since I started on the Go team a few years back, there's nothing that's impressed me more than the community and the culture that you all have built here. The Go project itself, not even counting the ecosystem, it's this vibrant and growing community of developers from all over the world who vote, comment, and then contribute to this enduring project. There's this large, robust library ecosystem as well, more than 1 million different modules. This is one of the most important things we have, and it's what we always need more of. Quality libraries make everyone more productive and unlock new opportunities that we as the Go team could never foresee. And we see Go really thriving in open source, which really bodes well as like a leading indicator of what we think we'll see in industry next. Programming language adoption, especially when you view it in the aggregate, it's fundamentally slow. A lot of stuff's already been written, and developers continue to maintain or improve them, and it would be really inefficient for these developers to go then rewrite these workloads in a new language. Nobody wants to fix what isn't broken. We don't want that either. But our objective, and more our opportunity, is to target new applications. So on this slide, we plot out the proportion of pull requests on GitHub by language per quarter for each of the major statically compiled memory-safe languages: C#, Java, Rust, and Go. So it isn't aggregated over the last 20 years like you'll find in a lot of benchmarks or surveys that ask developers, what language do you use? This is a quarter-by-quarter breakdown, sort of like a first derivative. And it's of actual work too, measured in pull requests. So as you can see, Go's ascent in red here, it's really pronounced. In the last few quarters, it's practically tied Java. And the same for Rust, by the way, in green. This growth is really so exciting for two reasons. First, because Go is growing in open source, it means that there will be more libraries for developers to use, furthering that flywheel of productivity for all Go developers and furthering the vision of a really productive, secure platform for production systems. And even more than that, it means that Go and the Go community are really well positioned for the future, ready for these big shifts in technology that happen from time to time. So Go and the Go ecosystem, they're better than ever, and they're ready for those moments when new code is written. But for all that success and excitement, again, it really all comes back to you, the community. And we all know that there are millions of developers that are actively using Go to build their applications, and we know that there's going to be many more to come. But even more important than that, there are hundreds of thousands of Gophers around the world who meet up, they come to conferences like this because they love Go. That's really irreplaceable. And that, most of all, is why the state of Go is strong. All right, I'll take some questions, but thank you.
If you have any question, raise your hand.
No questions?
There are probably tens of thousands of open issues on GitHub, and there's a constant stream of people yelling at the team to get this done or get that done. And you can use some metrics like upvotes or like big companies, but exactly what is the process for deciding what gets done next? Because I know there's the proposal reviews, but the proposals are not necessarily priorities, right? So.
Yeah, it's a good question. Well, it's hard. It's hard to sort of gauge, but the mission statement, right? Go is the most productive platform for production systems. That's the first place we start with. We think like, all right, does what we're doing in the scheme of all the stuff we want to prioritize, how do we continue to make sure that it is productive, a platform, and also suitable for production systems? If we see an opportunity to kind of create like, whatever the request is, if that fits within the mission and we're able to continue to persist the end-to-end experience, well then that'll bring it to the top. So it's kind of like an art maybe more than it is a science of upvotes and whatever else, trying to take all the different dimensions of the request and try to decide. If there are enough loud voices about it, maybe it gets us a little bit more of a focus on it. But again, we try to do these things really deliberately. It took like a decade to bring generics in because we didn't want to do that wrong. So the objective is to keep, Russ Cox has a talk, keep Go boring. That's the objective in this programming language, is to be very slow and boring about it, because we think that's a good thing. But the thing does evolve. So when we see proposals or requests or anything like that, we think about the framework of the mission and whether we are able to use our resources to get that done, and it would make sense in the greater picture.
Hi, Cameron. Thanks a lot for a great talk.
Thank you, Ron.
My question is, it seems like there's been a lot of growth in external contributors to Go, and that seems like a very good thing. It's also, though, very much still a governance process managed by Googlers who are part of the Go team. This is definitely in contrast to some other programming language where the governance is, much more distributed. Maybe you could comment on what you think, like the benefits of the semi-centralization, if you will, and where that sort of goes for the future as far as extending non-Googlers to be contributing to Go itself.
Yeah, sure. I love this question. So, Go is led by Google, and that's not true of all languages. Some are maintained or led by a foundation or something like that. So that's a key distinction here. And because Google retains the governance of Go, a couple of things come out of that. One is that Google contributes a lot more to it. Like, we fund the team that sort of has the core, sort of builds this thing out, and so that's, I think, probably an advantage, having more people working on it full time. And then there's also just the fact that what Go represents to Google is an opportunity to kind of demonstrate to developers that we care about them. It's a way for the company to build trust, most of all. We don't charge for it, we never will, and it's always going to be an open source project. Those things are set in stone. But by making sure that there is a funded team that is kind of always contributing and keeping the guidelines in a way that we think develops trust with the community, we think that creates a beneficial, symbiotic relationship with the community. Now, more specifically to your question, I think that having the governance be more centralized has sort of pros and cons, but I think one of the key pros is that the team that has created this project to start, folks like Russ, Robert, and others, they are still there to ensure that the principles that originally created the idea of making sure it is an end-to-end platform with certain sort of requirements of simplicity, ensuring there aren't any sort of mistakes, ensuring it's boring, ensuring we move slowly. All those things are enforced. They're set out in the beginning, the compatibility promise, all those other things. Those things are ensured because there's a team. The same people who set it out to begin with are still responsible for keeping it going. So I totally acknowledge there are pros and cons, but that's what I think the pro is.
I saw you first, I think. Yeah, sorry.
Hi, Cameron. That was a lovely talk.
Thank you.
You mentioned that you're looking at AI as the next frontier for Go. Do you have a strategy for competing against PyTorch and CUDA?
No, and that's so I sort of snuck that into this talk later on as something that I'm thinking about, and that I thought I'd use this opportunity to sort of solicit sort of ideas. I think what we know is that Go is still the language that folks reach for these kinds of like cloud infrastructure, critical business system extensive services. Like it's still, the one, and it grows explosively year over year. It's actually the best thing about being a PM for this thing is that every year it grows so much, and I get to go celebrate it everywhere, you know. And it's just the quality of the thing itself that makes it happen, and not anything that I do. But I do want to keep my eye on it because maybe what you said is very important. Maybe it's not. I'm really not sure at this point. What I think the important thing is to ensure that the community is able to build what it needs to build to support everyone else. That's where we can block them, and that's what I want to make sure we don't do. I don't think that we are able to ourselves, though, build out the whole ecosystem of things, and that's not what we want to do either.
Thanks.
Yeah.
Who was, yeah. How am I gonna get there?
Hey, yeah, great talk. Quick question. So looking back at the history of Go, and obviously you talk about C++ and unnecessary complexities and too many features. The whole founding pillars of Go being keep things simple, don't overcomplicate. I think it's really interesting looking at the Go version 1 compatibility and how you continue to keep each version compatible. Yeah. Is there a risk at some point that, and I've seen this in so many other runtimes, that you actually end up overcomplicating the runtime to support backwards compatibility rather than essentially breaking changes for good to ensure that you keep the language simple and ultimately you put the most advanced optimizations into the runtime?
Yeah, that's the trade-off. So there's like a multi-dimensional trade-off. One is, well, we risk overcomplicating, but say we don't want to do that. Instead, maybe we risk not moving fast enough. I think that's the real risk, because I think the other maybe founding thing here is do not overcomplicate. So I think that is what I really think is a risk, is that we just don't introduce something because it might break the thing. It's possible. That's part of why we introduced the forward compatibility stuff, so that we, for example, can fix the loop variable semantics has been a thing forever, but we didn't want to break people's programs if they'd relied on it. But now we have this capability of being sure that you can try it, see if it does break you. If it does break you, emulate the old behavior. That provided a little bit of a foundation to try to fix things that are glaring issues. But I don't think there is a risk of overcomplicating as much as there is a risk of not addressing something that has not yet come up. All that said, look, it's the nature of having like an enterprise-grade programming language. We think that this compatibility part is really the most important part. There's nothing worse than not being able to rely on the language. And it introduces a whole new risk of security problems. If you worry about upgrading because it might break your stuff, well, then you might not upgrade and you might just leave yourself vulnerable to something else. So this has been our way of trying to kind of like balance between all of the different competing interests and issues, and ensure that one, you can rely on this thing and not be a headache, and two, that you can make sure your applications are secure. That's where we sit right now. As a programming language, I don't think it's necessarily that bad of a thing. It's not, we're not trying to, like the thing you referred to, the C++ thing, we're not trying to like show you, hey, here's another way of doing the same thing you can already do. These concepts are pretty well sort of ingrained. Generics was maybe the big issue. And so I think we got through that, and that was the big win. Thank you for the question, though. Anyone else?
Ciao. Thanks for the talk. And I would like to expand on the previous question. So what I wonder is when, for Go, it is time to stop with new features? Because every application usually, at least the one applications I know, they die of new features. Okay, so Go puts a strong hold on this fact that it does not want to replicate C++. It's the foundation, as you were mentioning. Okay, so when do we stop with the new features, and when it's the right time? That's my...
Yeah, that's a fun question. So I'm not sure exactly, because I don't think we're that close to it, because you know what we would do is there's always work we can do to make Go more performant, for example, and nobody objects to Go performing better. Like right now we're looking at sort of RAM efficiency. I think I showed on the slide earlier. You know, that was that we've realized that as time has gone on, RAM has not become cheaper and more abundant after a certain point. And so we're thinking, well, maybe we should spend some time making sure that Go is RAM efficient now that the previous assumption of RAM's continued growth and efficiency has sort of come to a stop. So now that's presented itself as a place where we can, under the hood, I don't know if these are new features so much, but work that we're doing on Go to make it better. If there's another thing that I think we have a long way to do more of, it's just continue to build more of the end-to-end platform. There's always just more opportunities to find things in the standard library, for example, that we could make better in order to ensure that, like, you know, this piece comes with Go out of the box, and that you don't have to try to like figure something out about that. Or if you're trying to get started, for example, you know, that's hard today, harder than it needs to be. And so we can always, you know, there's a way of sort of answering your question from the side. Like it may be that new features in the language, maybe that will reach its end sooner, but there's more things that can be done to make the experience better for everybody. Now, maybe one day down the line, there's going to be none of that left either, and Go will just be on everything everywhere, and that'll be cool. And you know, maybe a future product manager can make that decision. But I think we still have enough of that stuff to do that it's not in the foreseeable future that we'll have to, you know, sort of figure out, well, what are we doing with our time anytime soon. But we will always keep it boring, and we'll always ensure that we're not breaking anything, and we'll always be very deliberate about new things that we introduce.
Thanks so much, Cameron. That was really interesting. I'm also really excited to hear you say just there that things maybe could be a little bit easier to get started with.
Yeah.
So I started with the language maybe 5, perhaps 6 years ago, and the getting started tutorials were amazing. They said, just open this file, put this code in here, compile and run it. And that was amazing. And now you create the directory, you open the mod file, you make some changes, you do a mod tidy, and then you run it. It could be a little bit slicker. Anybody who's run Go mod tidy knows that it's smart enough to understand all of the things you're asking for and generate the necessary files. Is there a thought in the team, or a proposal perhaps, that says we could actually make it just that simple to get started again? And if we find that all of these metadata are missing, make sensible assumptions, generate something helpful, so that we can go back to the concept of just open this file, put some content in, and run your code sample.
Yeah, 100%. 100% that there's a thought in the team, you know, many thoughts that has gotten to be less easy to start up. Another, you know, corollary to that is that we think our documentation on go.dev is a little bit, I mean, could use some work, and that's part of sort of the work that we want to do first, is try to ensure that you're not relying on some outdated material from us. Thankfully, the community has a ton of material out there. There's a lot of good stuff from third parties to supplement that. But the specific question you ask isn't a thing on the immediate near-term roadmap. It comes up a lot when we as a team meet to talk. Pretty much every time, you know, everyone says something similar to what you say. I can't guess as to when something like that will happen. I think you can maybe take some comfort in knowing that we're, you know, well aware of it, and that if and when the time comes to spend some resources trying to fix that, we will. It's always a prioritization question about what else can we do, what else is on the horizon. And so for the short-term roadmap, no, but I wouldn't be surprised if you'd see something like that in the next few years.
Last question.
Thank you for the talk. I have a question about error handling, the most second wanted issue in Go. And another question, okay, first question, do you have any plan for making error handling better or not yet? And the second, I saw an initiative for Project Lyot in Go.dev.
For Project what?
Lyot. Do you have plan to make it better, or it's only initiative?
Okay, so through the first question, air handling. First, I just want to say I kind of like the way air handling is, but I know that I'm, perhaps in the minority. And it is a topic that is actively under sort of discussion internally, where trying things out. What about this? What about that? So that one I would say is farther along than the previous gentleman's question. There's a lot of active sort of discussion about what would be the sort of best way to do this. Because remember, once we do, we're stuck with it. And that's the theme I keep returning to. It's got to be deliberate and correct. To your second question, I actually don't know. So I hate to end the Q&A on that, but my answer is I don't know the answer to that one.
Well then, thank you all. Thank you, Cameron, again.
Yeah, thank you, everyone.